Ladies and gentlemen, we are here with our 6th-hour Blended Honors Geometry Live studio audience. And we are going to be getting into rhombi, kites, and squares. Oh my! All right, firstly, we'll want to address some of the properties of rhombi, kites, and squares. Oh my. You can take a look at your family tree, which is located on the Chapter 5 main page, to see all the different properties. We'll go over some of the highlights right here. One lovely aspect is that all of these have perpendicular diagonals. Now, in a kite, in this one, KT would perpendicularly bisect IE. In the rhombus, they perpendicularly bisect each other, and the same happens in a square. But a square also takes the properties of a rectangle, which is congruent diagonals. So if you bisect congruent diagonals, all the bisected parts are also congruent. In a kite, we have a couple pairs of congruent sides and a couple other pairs of congruent sides. We've got some angles that are also congruent. These two angles are congruent in a kite. And that's pretty much about it for our kite friend here. For our rhombus and our square, they take all the properties of a parallelogram, okay, and then they branch off from there. A rhombus will take all those parallelograms, so opposite sides parallel, but it's basically a parallelogram with congruent sides. So all of these sides are congruent. All right. And a square would take that as well, obviously. I think we all know that a square has all congruent sides. And it has, obviously, right angles, 4 right angles. So it takes the right angle aspect of a rectangle. Lovely. There's a few other ones that you can take a look at on the family tree, but yeah, I would have that up as you go through this video. Pop onto that family tree. It'll be very helpful in the next couple problems. Alrighty, so I just give the class a little bit of time here, the live studio audience, a little bit of time to think about these. You may want to do so yourself. Hit pause, see if you can answer them, and then we'll go over the answers right now. Grace, are you ready?
No.
Excellent. Alrighty, a quadrilateral is a square, always, sometimes, or never?
Sometimes.
Sometimes. If all those sides are congruent, and it's got 4 right angles, I think we got ourselves a nice little square. Alrighty, a square is a rectangle.
Never. Always.
Always.
Ha!
Let's think about that for a sec. A square has 4 right angles. Its opposite sides are congruent. Its diagonals are congruent. Right? Diagonals bisect each other. It has all the properties of a rectangle. It just happens to have 4 congruent sides instead of only the opposites. So it would always be a rectangle. Would a rectangle always be a square?
No.
No, it would sometimes be a square. Okay, so the other way would be sometimes. A rhombus is a parallelogram. Always. Does it have opposite sides parallel? Heck yeah, so it's a parallelogram. That's right. I saw that, Jake. That's good. You're like, yeah, it is. Heck yeah. All right, a rhombus is a quadrilateral. Always. Does a rhombus have 4 sides?
Yes.
That's all it takes to be a quadrilateral. Woo-woo! And a parallelogram is a square.
Sometimes.
Sometimes.
Ha!
Sass.
You said always.
All right. So, parallelogram is sometimes a square because it has opposite sides parallel. That's really all you know. It could have all sides congruent. It could have 4 right angles and still be a parallelogram. So that one is just a sometimes. Lovely. Any questions, children? There are no questions. We are moving on. Ooh, this one's lovely. And it says similar problem on quiz. I wonder if that means that it could be on the quiz. All right. What name best describes the quadrilateral below? I would plot those points first.
Yeah, I'm not trying this.
And maybe have a little hypothesis as to what you think it might be before you prove it. All righty. So we've got our points plotted. How do we usually like to go about these types of problems? What can we look at to see what kind of quadrilateral? I like slopes. All right. Any ideas as to what this might be at this point?
Square.
Okay, so we're thinking a square right now.
Or rectangle.
Or it could be a rectangle, could be a kite. Who knows? Could be a rhombus. We're going to find out though. But all right, now our thought is square. Okay, So let's find our slopes. If we count out these slopes or use slope form or slope formula, we'll see that this one is -1, this one is +1, -1, and +1. You're going basically over to the right. What is that? 6 and down 6. Okay. So it's, yeah, all ones and -1s. Cool. Well, what does that tell me about the angles at all my vertices B, E, F, and G? The opposite sides are.
Oh, yeah. No, yeah. Parallel.
Opposite sides are parallel, but the consecutive sides
Or congruent.
Oh,
Perpendicular.
perpendicular.
Yeah.
So that means I've got 4 right angles. Lovely. Okay, so what does this narrow it down to? What 2 quadrilaterals have 4 right angles? Caitlin. Square and rectangle. So it's either a square or a rectangle. So you have to think about what will differentiate it between being a square and a rectangle.
If they're the same length?
If your sides are the same length, it's a square, right?
Yeah.
Heck yeah. What else could I do? Because I don't want to do distance formula 4 times.
Slow.
Kirsten, what did you draw in on the board for us that we can't see yet? I'll draw them in now. What are those green lines?
We did that.
Yeah,
Where'd you get that?
those are my
Diagonal.
diagonals. Very good.
Yeah.
So, what's different about my diagonals in a rectangle versus in a square?
They're congruent in a triangle.
They're
I'm
all-
not triangle, square.
They're congruent in a rectangle and in a
All of
square.
them are
Yeah.
My diagonals, though. Just those green ones that I drew on there.
Oh, the same. They should be the same length. Both of them should be the same length.
Rectangle and square both have same length diagonals.
Oh my gosh. I'm clueless.
So in a rectangle, our diagonals don't have to be perpendicular. If they are perpendicular, it becomes a square. So if these diagonals were perpendicular, then I'd have a square. And if I look at it, I've got a 0 slope for my horizontal, and I've got an undefined slope for my vertical. Those two are perpendicular. They form a right angle, so this has to be a square. Excellent. Now, if those two diagonals were not opposite reciprocal slopes, they weren't perpendicular diagonals, then it'd be a rectangle. So I can narrow it down first off with the slope of my sides and then with the slope of my diagonals. But we can focus pretty much on slopes for the majority of these, which is lovely. So what do we know about heights in this particular problem? We've drawn some things on the dry erase board, but we can't see them right here. So what do we know about heights that's going to be helpful here?
The two sides are perpendicular.
All right, so we got the diagonals that are perpendicular, so we get a right angle there.
KE and KI are congruent.
These two are congruent. And also, what was it?
ET and IT are congruent.
Excellent.
E. Oh, never mind.
Well, I guess the other aspects that we have drawn up there aren't necessarily important for this particular problem with the angles and whatnot. But where can we go from here? How do we start this with the information we have? Caitlin.
You said 5x equals 90.
Woo! Where did my mark go? There we go. 5x equals 90, so x is going to equal what? 18. Very good. Now, what can I do with this information? Caitlin, you're on a roll.
Plug it into that equation.
All right, so I'd have 2 times 18 plus 5. And what does that end up being? 41?
Yes.
And then when I do it over here for the 3x minus 2, what do I get? What was that length? 54? 52?
Yeah, 52.
She doesn't know. She's just saying whatever. I don't know.
52 works. I think I remember this problem. All right. So I got 41 and 52. And we said that these sides were congruent, right? So this one has to be 41 as well.
And it is 52.
And this has to be 52 as well. Very nice, Kirsten.
Thank you.
And then you add them all up.
Add them all up.
Okay, 41 plus 41 is 82. Plus 52.
41 plus 52 is, 41 plus 41 is 82, yes. Very good. And then 52 gives me 186
No.
altogether?
Good
All
job.
together.
All together. Yeah. America, freedom, rock and roll.
What day is this video for?
Today.
Oh.
Fun. You're already done.